So this is part 4 of Structure and Cross-Linguistic Phonetic Realization. So in this part of the talk, we're going to move towards cross-linguistic extensions of phonetic analysis. So the uniformity constraint that we've been exploring in this talk, as I mentioned, it should extend to other languages, other phonetic dimensions and segments, and to some degree we have been able to look at this, to some degree. So for VOT, we did look at other languages, and we did find that this uniformity constraint might also be present in American English sibilant place. But it would be good to push this further, figure out what the limitations of uniformity are, and whether it is actually a universal constraint on phonetic realization. To do this, we really need to start making further use of large-scale multilingual speech corpora. And as I mentioned in part 1 of the talk, these have been really hard to get a hold of until recently. So previous cross-linguistic phonetic analyses have been limited to a small-ish number of languages with available data, or have relied on previously reported measures from the literature, like we did for VOT. But again, now that we have the computational power and these corpora are starting to be developed, we really have the means necessary to start doing substantial cross-linguistic phonetic analyses, and we are now working in that direction. So I've been fortunate enough to work with the Wilderness Corpus, which is a corpus of Bible readings with utterance level alignments for over 600 spoken languages. And what's really great is there's about 20 hours of speech per language, which is a lot of speech data, especially for a phonetician or for phonetics research. The alignment accuracy does vary, but that's apparently a work in progress. From this, we've been able to create the VoxClamantis Corpus, where we performed forced alignment on those utterances using 3 G2P toolkits, and then extracted several phonetic measures from those audio files. Forced alignment, if you're unaware, is simply an automatic alignment of the transcription to the audio file. And specifically what we did here is we have phone level alignments. So it's not just words or utterances, but individual phones or phonemes that are aligned to certain units of time in the audio file. We use 3 G2P toolkits to accomplish this: Unitran, Wikipron, and Epitran. Unitran is a universal G2P system that is very convenient and useful for many speech technologies and avenues in speech research. For phonetic research, however, it's really important that you have a decent understanding of the representation of the segment that you are working with. So taking some guess as to what the segment is not ideal for much of the research that I would want to do for phonetics. Wikipran and Epitran, on the other hand, are language-specific G2P systems with a little bit more reliability regarding the mapping from the orthography to the phonetic transcription. So which phone is it that occurs at this unit of time? Is it accurate? And for Wikipran and Epitran, there's a little bit more accuracy in that mapping than what you might get out of Unitran. So between Wikipron and Epitran, which we consider the high-quality G2P toolkits, these cover about 42 languages in the VoxClamantis Corpus, and we just extracted the phonetic measures from the phone level alignments. We can then use this corpus to further investigate this notion of uniformity. So in the last section, we looked at uniformity in sibilant place of articulation in American English, and we were able to look at sa, za, sha, and ja, and we found strong covariation of talker-specific means between segments that shared an anteriority feature value. When we look across the 18 languages in our sample that happen to have both S and Z, we find a similar relationship. So the idea for uniformity is that S and Z have a shared plus anterior feature, which we've approximated with the mid-frequency peak, and we find strong covariation at the language level, and it's very close to the line of identity. So this corroborates what we found for American English, but at the cross-linguistic level. That said, it's still a kind of small sample, 18 languages, 22 readings, and only 6 language families. So for some languages, we have multiple readings of the Bible. In addition, we looked at vowels, which I haven't looked at yet within a language, though other researchers have. So other researchers have identified that there is this expected uniformity, as I would call it, in the implementation or the realization of the vowel height feature, which would correspond to the vowels F1. And when we look at vowels that share a plus high feature or share a vowel height feature, like E and U, we find that, again, there's a pretty strong correlation across languages. So the correlation is at 0.79. And here we have 38 languages from 11 different language families. So again, this is suggesting that maybe there is something to uniformity in vowel height, but still preliminary research. So there are a lot of potential future directions with VoxClamantis specifically. So there's a fair amount of cleanup and development still necessary for this corpus. So we have limited G2P systems, which really limits what we can do with the phonetic analysis. So there's a definite need to continue building improved G2P systems for alignment. And while we've implemented a fair amount of automatic cleanup, there's been minimal manual cleanup. So it would be nice to do a little bit more manual cleanup of the corpus to get more refined phonetic measurements so we can properly investigate cross-linguistic phonetic variation and systematicity. That said, there are some limitations to the VoxClamantis and Wilderness corpora. There are a high number of single-speaker languages, which means it's a little bit more difficult to disentangle cross-talker variation from cross-linguistic variation. That said, it's still better than nothing, and it is the largest, it has the most number of languages that I know of in a multilingual speech corpus. And the other nice thing about it is that they're all reading the same semantic content. One other limitation, though, is that some recordings are dramatic readings with music in the background, so it would be good to identify where that occurs so we're not extracting phonetic measures from those locations where it might be impacted. The development of the common voice corpus is very promising, but it still requires a fair amount of processing and cleanup. So that is a future direction that would be nice to go in. There are also several future directions that are related to just more general questions about cross-linguistic phonetic variation. So with respect to uniformity and phonetic realization, what are the phonetic targets? Am I guessing correctly in what they are, or is it something different? How do we go about studying that? Second, is the phonetic realization of a feature restricted by manner of articulation? So I've talked about uniformity as, say, uniform realization of the plus spread glottis feature. However, laryngeal gestures for fricatives are known to have different articulatory specifications than laryngeal gestures for stop consonants. So it's not just that it's a single feature that needs to be uniform, perhaps it's a single feature within a manner of articulation. And finally, is uniformity more specific to obstruents than vowels? So the correlations tend to be stronger in obstruent measures than they are in vocalic measures, or are we just measuring the wrong acoustic correlate to observe structure in the targets? So that gets back at the question of what are the phonetic targets? Are we getting them right? And what are the acoustic correspondences of those phonetic targets? And additionally, just how universal is uniformity? I think it would be really interesting to identify some outlier languages to investigate what's going on with respect to them relative to others. And uniformity is just one constraint. What about other universal influences on phonetic realization? So a big one might be perceptual distinctiveness or phonetic dispersion. All in all, though, we need more cross-linguistic data suitable for phonetic analysis to identify the limits of structured variation and learn more about the constraints on the phonetic grammar. And this cross-linguistic data simply involves the collection of speech data and also accurate transcriptions and G2P systems. So in conclusion, we do find evidence for uniformity in stop VOT and sibilant peak frequency. We find it in several languages and cross-linguistically, and from data that I haven't presented here, we've also found it in child speakers in L1 and L2 grammars. So it's not simply that everything co-varies. So it's not just that, things are coming out of the same vocal tract. There does seem to be something about the shared featural representation or some shared representation, subsegmental representation, that ties the phonetic realizations together. Large-scale corpus approaches also provide the opportunity to analyze the extent and limits of phonetic variation across languages and talkers, and structured variation in this notion of uniformity in phonetic realization have important implications for phonetic and phonological theory, L1 and L2 acquisition, and mechanisms of speaker adaptation and identification. And there are several feasible extensions of this research in forensic speech science, language acquisition, bilingualism, and many others. So I'd like to thank you for your attention and several people who have been involved in various parts of this study, whether primarily or supporting me in this research. And I look forward to your questions.